So, why do we need to study all this predicate logic? What does it do for computer scientists? Well, lots of things, from writing specifications to knowledge bases to automated theorem provers. But one of the more direct applications, specifically of predicate logic, is for querying databases. So how does predicate logic help us query database? Remember, we were talking about predicates and relations being kind of two sides of the same coin, where for every predicate you could make a relation containing everything where the predicate is true, and for every relation you could make a predicate which tells you whether something is in the relation or not. So we could use those predicates built on database relations to write formulas, and then we could use those formulas to query databases. So a query, it can be just a statement that returns true or false, or it can take some free variables. And often when it takes free variables, there is one additional step, and that is returning all the possible values in the database of those free variables for which the query is true. So let's see some examples. So we already looked before at relations prof data and course data that you might find possibly in some university database. So the prof data lists first name and last name and the office number of faculty, and the course data for every course offered in this semester would have name of the course, time when it's offered, dates, room number, and the last name of the instructor who's teaching it. So, how can we query a database like that? What kind of questions can we ask? So suppose that we want to find out if someone called Manrik is teaching COMP100-081. So first, let's define predicates corresponding to the relations. In the predicates, the input to the predicates will have exactly the same names as those elements that we had here for the columns in the database. Say first name, last name, office, and so on. Really, the only thing that changes is, rather than thinking of prof data and course data as two sets, we are thinking about them as, well, small queries that tell us yes or no. So now let's use those two predicates, prof data that takes three values, first name, last name, and office, and tells you yes, somebody with this first name and this last name has this office, or no, there is some kind of mismatch. And the course data with course, days, time, room, and instructor, and make a query which would be true if and only if Manrik is teaching COMP100-081. So first of all, notice that if we had Manrik's last name, we could almost immediately ask the query to course data. And the way we would ask it would be something like this. Is there some field with COMP1000 in the first column, something in the second, something in the third, something in the fourth, and the last name of Manrik, Matamantera, is the last column. Even to ask this query, we would already need quantifiers, because what we would want to say is there some values for the second, third, and fourth columns, so that together with those values, COMP1000 in first and Manrik in the last one, we would get an entry. So using this idea, we could combine the prof data and course data predicates and say, is there somebody with some last name and the first name Manrik, as we could look up in prof data, and the somebody with this last name is teaching the course COMP100-081 in course data. But this would be an error because prof data takes 3 inputs, course data takes 5. So we really need to fill in those question marks. Even if we put some kind of placeholders, it's not enough because it's a question mark, but question mark is not the same as Monday, Wednesday, Friday. So if we query the database with this, it would just say no. Well, there is nothing with question marks in those places. So in order to actually make the formula, we need to use existential quantifier again and put existentially quantified variables in all of those places that we don't care about. So we do care about Manrique last name because this is what ties our two predicates together, but everything else you could just put some arbitrary letters. And I put the first letter of every field, like O for office and D for days, just to save space. So now finally we get something that the database could be happy about, a formula which is true in the database if and only if Manrique is teaching COMP100-081, which he actually not teaching because it's Shireen Bongay that teaching 1001. Okay, so let's try to make some other formulas. Manrique is not teaching COMP10001, but this is a way too specific predicate. In general, we want to write something that we could use to find out whether Professor X is teaching a course Y, no matter who X and Y are. The only thing that we need to do for that is to replace the name Manrique with X and the course name with Y. And we get the same formula that now works not just for Manrique and COMP10001, but can check for anybody whether person with this first name is teaching the course called Y. So here, X and Y are free variables. So X and Y can be substituted by anything we want, or again, we may try to see for which X and Y's this formula is true. But before we do that, let's try to write one more thing. Now that we have who teaches what, we could use it to check that everybody teaches something. Well, maybe again we could do it by just going over last names, but let's just reuse the formula that we just wrote. So we want to check that everybody teaches something. That is, for all first names of instructors, there is a course that somebody with his first name is teaching, or the person with his first name is teaching. So for every instructor X, there is a course Y, such that this instructor teaches this course. All we need to do is to add for all X, exists Y. How do we know that it exists? And for all, well, let's just read the sentence. Everybody, every, so it's a universal quantifier, teaches something, something, that's an existential quantifier. Something refers to a course that they're teaching some course, and everybody refers to whoever is doing the teaching, the name of an instructor. So every instructor teaches some course, for all X exists Y. So finally, suppose now we want the database to tell us all pairs X and Y such that X teaches Y. But wait a moment, so far we were in a logic world. We only talked about things that are true or false. How do we get a relation? Well, we just reverse the process of making a predicate out of the relation and returns all pairs X and Y such that the formula that we wrote before is true for this X and this Y. And this will be a relation, let's call it teaches, of person X teaches course Y.